So, in this video, we will try to understand how to derive the relation between small changes in resistance for small changes in length and area of cross section. Okay, we know that the resistance R is given by rho L by A, where rho is called as resistivity, L is called as the length of the conductor, A is area of cross section. We know all these things. Now we will see for a small change in length of a wire how the resistance will change, what percentage of resistance changes, and for a small change in volume, for small change in area, what is the percentage change in resistance. In order to know that, what I am trying to do is I am just applying log on both sides. So if you apply log on both sides, you will get log R is equal to log rho plus log L minus log A, because I have applied the properties of logarithms here, so that I got this equation. Now I'm differentiating this with respect to R. But before differentiating, first we need to know what is the parameter that we are changing, either length or area. Okay. So first, for small changes in R, for small changes for small changes in length, how the resistance will change. Okay. So differentiating with respect to R on both sides, if you observe, for log R, the differentiation is 1 by R and it into delta R. I am differentiating on both sides. Rho is a resistivity which depends upon the type of material, hence it is a constant. So differentiation of log rho is 0. Similarly, differentiation of log A is also 0, because here we are considering only the change in length, keeping the area as constant. Therefore, the differentiation of log A is also 0. And what is the differentiation of log L? It is 1 by L delta L. Therefore, for small changes in length, the change in resistance is given by delta R is equal to delta L by L. Okay. So this is one observation we can make when we change the length, keeping the area as constant, how the change in length affects the change in resistance. Now we will see one more scenario where the area is changes a little bit, maintaining the length as constant. Okay. Therefore, what we can write here, for small changes in area. For small changes in area, I am using the same equation for both the things. Okay, I am differentiating on both sides. Log R differentiation is 1 by R delta R. Okay, and it is equal to, for log rho, the differentiation is 0, because rho is a constant, and here we are changing only the area. That's why length is also constant, hence differentiation of log L is 0. now for now for log A, you can have minus log A differentiation is 1 by A and delta A. Now what we can understand, for small changes in area, delta R by R is equal to minus delta A by A. Okay. Now we will see the third situation. So the third situation is if radius of the conductor changes, for that small change in the radius of the conductor, how the resistance will change. In order to find that, first we need to convert the first equation in terms of radius. Let me convert it. So first equation is log r is equal to log rho plus log L minus, in place of A we can have pi r square, okay, because it is the area of a circle and we are assuming the conductor or the wire is having a circular cross section. Therefore, in place of A we can substitute pi r square, hence we will have minus log pi r square. Okay, just I am just modifying this equation a little bit. Log r is equal to log rho plus log L, and I am just splitting into two logarithms this one, so it is minus log pi and minus log r square. Log r square can be written as 2 log r, so 2 log r. Now differentiate on both sides for small changes in radius. Okay, so for small changes in radius of the conductor, how the resistance will change. For log r, the differentiation is 1 by r multiplied with the dr or delta r, both are same, and it is equal to the differentiation of log rho, the differentiation of log L, and the differentiation of log pi. All are zeros because all of them are constants. Here we are concentrating only on small change in radius. That's why if you take the differentiation for minus 2 log r, what you will get is minus 2 into, for log r you will get 1 by r into delta r. Therefore, for small changes in radius, the change in resistance is given by delta r by r is equal to minus 2 into delta r by r. Okay, in this way we can understand how to derive the change in resistance for small changes in, first we have seen for small changes in, let me change the color. First we have seen for small changes in length of the conductor. So this is the situation. For small change in the area of cross section of the conductor, this is the situation. And for small change in radius of the conductor, this is the situation. Okay, I hope this video gave you an understanding on how to derive the change in resistance with respect to small change in length, area of cross section, and radius of the conductor. If you really like this video and think that this video is helpful for you, please hit a like button and subscribe to our channel. Thank you very much.